assume sequence is geometric. That will give you 1 mark. Now, if it's geometric, remember, whenever you have consecutive terms in a geometric sequence, right, and it's expressed algebraically, what you always want to do is find an expression for your common ratio, right? Because with that being said, you're able to form an equation in terms of this variable, and then you can solve it. So what I'm going to do is I'm going to say, well, the common ratio is going to be any term divided by the term that precedes it. So I'm going to say that the second term, which is 1 plus 2k, is divided by the first term, which is k. This has to equal, well, another way of expressing the common ratio, because it's the same throughout the sequence, isn't it? The third term, which is 3 plus 3k, over the second term, which is 1 plus 2k. Now, this is an equation. This shouldn't hold, right? We know that this is not going to work. So we need to show that this equation isn't true. It doesn't hold for values of k. Now, how do we do that? Well, let's get rid of the denominators. Let's cross multiply. So if I do that on that side, it's going to be 1 plus 2k all squared. And then this is going to equal times that k up there. It's going to be a 3k plus a 3k squared. Now, expanding that bracket, that's going to be a 1 plus 1 times 2k is a 2k, double that's going to be a 4k. And then squaring 2k is going to be 4k all squared, isn't it? 4k squared, and that's going to be a 3k plus 3k squared. This is a quadratic equation. Let's move everything from right to left. So the k squared terms is going to be just k squared, isn't it? The k terms is going to be a k, and we've got the plus 1 already on the left. This is equal to 0. Now, remember, we know that this isn't going to work, so we need to show that this isn't true. K squared plus k plus 1 is equal to 0. It doesn't hold. How do we determine the number of solutions of a quadratic, right? We could just apply the discriminant. So let's do that and see what we get. So the discriminant we know is b squared minus 4ac. Now, in our case, a, b, and c are all 1, aren't they? So it's going to be 1 squared minus 4 lots of 1 times 1, which is just the same as 1 take away 4, which is negative 3, which is less than 0. And this means that there's no root. So therefore, we're going to say there are no real roots, right? So therefore, k squared plus k, in fact, does not equal 0. This is a contradiction. Remember, we assumed it was geometric, so this equation was meant to hold. We've proved that it doesn't hold. So what you're going to say now is the contradiction. This is a contradiction. This is a contradiction to the original assumption, right? Original assumption. And then now to get the final mark, you're just going to say, therefore, the sequence is not geometric. And that's it. Finished.